So that is a by decomposition or a precipitation of emulsifying agent, right? If emulsifying agent become decomposed or become the precipitate out, that time there are chances of phase separation on cracking, right? So as I said, that is a if our emulsion contain the alkali kind of, if our emulsion, that is a emulsion contain the alkali soap, that is a, there is a one example, that is turpentine liniment. So turpentine liniment contain the alkali soap, right? And if we accidentally or intentionally add the acid into the turpentine liniment, that time there is a chances of decomposition of our emulsifying agent, whatever the emulsifying agent are used. Emulsifying agent means our alkali soap, right? Emulsifying agent is alkali soap. If acid we added into the alkali soap containing emulsion, that type our emulsifying agent become decomposed, and due to the decomposition of our emulsifying agent, there is a chances of phase separation and or cracking, right? These are phase separation or cracking means instability, right? So then if an NaCl added to sodium or a potassium soap emulsion, emulsifying agent precipitate out may lead to emulsion cracking. So this is the about the decomposition of our emulsifying agent and how the decomposition happening or occurred. If we acid added to alkali soap emulsion, that time our emulsifying agent become decomposed, and due to that emulsion cracking, right? And there is a precipitation. This is the reason of our precipitation, that is example, right? So if our emulsion contain the sodium or potassium soap, emulsion contain the potassium or sodium soap, right? Suppose whatever the preparation we prepared, and that preparation include the or include the sodium or potassium soap, or made up of with a sodium or potassium soap. That time we accidentally or intentionally used add the NaCl into the sodium or potassium containing soap emulsion, that time there is a precipitation occurred of our emulsifying agent, right? Our emulsified agent become precipitate out, right? And due to the precipitation of our emulsifying agent, we know that that is a emulsion cracking, right? There is phase separation of emulsion happening. So by this way the cracking occurred, right? By this way the cracking may occur, either it is due to the decomposition of our emulsifying agent, or either precipitation of our emulsifying agent, right? And precipitation occur due to addition of NaCl, and decomposition of our emulsifying agent occur due to the addition of acid. So you should know that why the precipitation occur, then decomposition occurred, right? So if we know that reason, that time we will overcome or solve the our problem, right? Or preserve the our emulsion from this kind of instability problem, right? So you should know thoroughly about it. So after the second reason, right, it is a second reason, that is by decomposition or precipitation of emulsifying agent. So there is another reason, that is by addition of common solvent. By addition of common solvent, so alcohol is a one kind of common solvent, right? So you should remember this, alcohol. So by addition of common solvent, if we add the common solvent to our emulsion preparation, that time also may chances of separation of our emulsion, right? If common solvent added to emulsion, which either miscible with disperse phase, emulsifying and continuous phase, emulsifying agent and continuous phase, right? So as we know, that is a common solvent like alcohol. If we add alcohol to the emulsion, right, common alcohol or a common solvent add to the emulsion, and that common solvent which either miscible with a disperse phase, or either our emulsifying agent or with our continuous phase, right? मतलब जो कॉमन सॉल्वेंट जो हम ऐड करेंगे, तो वो क्या होगा, चांसेस होगा कि जो इमल्शन में जो डिस्पर्स फेज है उसके साथ सोलूबल हो जाएगा, या सोलूबल कर देगा, डिस्पर्स फेज को सोलूबल कर देगा, या फिर इमल्सिफाइंग एजेंट को कॉमन सॉल्वेंट में सोलूबल कर देगा, या फिर कंटिन्यूस फेज को कॉमन सॉल्वेंट में सोलूबल कर देगा, ठीक है? तो इसकी वजह से भी क्या होगा, ड्यू टू दिस रीजन फॉर्मेशन ऑफ वन फेज और क्लियर सॉल्यूशन में लीड टू इमल्शन क्रैकिंग ड्यू टू दी miscibility or miscibility of disperse phase or emulsifying agent or a continuous phase. There is a formation of one phase, there is a formation of one phase or formation of clear solution, right? And due to the formation of one phase or clear solution may lead to emulsion cracking, that is a separation, right? One phase, we know that our emulsion is a two phase biphasic liquid preparation, right? We know that is our suspension and emulsion is a biphasic liquid preparation. Why it is called biphasic emulsion? Why it is emulsion called biphasic? Because emulsion prepared with two kind of phases, that is a continuous phase and a disperse phase, right? And if we add the common solvent into the emulsion or biphasic preparation, if we add the common solvent into a emulsion preparation, that time there is a, due to the solubility of due to the dissolution or miscibility of our disperse phase or emulsifying agent or continuous phase, there is a formation of one phase, right? If our preparation become one phase, that time we will not call it our, it is a emulsion or biphasic preparation, right? Or due to the common solvent, our preparation become a clear solution, right? And due to the formation of one phase or clear solution, may chances of occurring the emulsion cracking or separation of our phase, right? So this is the one of the another reason, right? One of the another reason by which our emulsion become crack, right, or separate out, that is the addition of our common solvent, right? So you understand that is why the common solvent responsible for cracking, because common solvent get dissolved with the डिस्पर्स फेज और इमल्सिफाइंग एजेंट और कंटिन्यूस फेज. एक तो कंटिन्यूस फेज को फेज के साथ क्या होगा, डिसॉल्व होगा, या फिर इमल्सिफाइंग एजेंट या फिर डिस्पर्स फेज, या फिर तीनों को क्या कर लेगा, अपने अंदर डिसॉल्व कर लेगा या फिर मिक्स हो जाएगा उसके साथ. तो मिक्स होने के बाद क्या करेगा वो, वन फेज, एक फेज का प्रिपरेशन या फिर क्लियर सोल्यूशन फॉर्म करेगा. एंड दैट क्लियर सोल्यूशन और ऑन फेज सोल्यूशन बिकम क्रैक्ड, right, become cracked or separate. And this is the reason, right, this is the reason of cracking. Though there is one example also there, that is the addition of alcohol to the turpentine liniment lead to formation of clear solution, right? There is a turpentine solution, we know that that is a sorry, turpentine, not a turpentine solution, turpentine liniment. We don't call the emulsion is a solution, right? Emulsion is not a solution, because solution made up of with a one phase, right? Emulsion is a emulsion because it is prepared with a two phase, right? So you should not call the our emulsion is a solution preparation, right? The addition of our alcohol to the turpentine liniment, so liniment is a one kind of emulsion, right, made up of with two phase. If we accidentally or intentionally add the alcohol to the turpentine liniment, that time that turpentine liniment become a clear solution. Become a clear solution means it become a one phase, it become a one phase or clear solution. And due to the clear solution or on one phase, that liniment become cracked or separate out, right? So this is the example, right? This is the example. So we can understand that or remember this reason, that is addition of common solvent, right? So there is a reason become the, if we accidentally add the alcohol to the turpentine liniment, and that liniment become a clear solution. So why it is become a clear solution? Because turpentine oil, soft soap and water are soluble with alcohol, right? Water is soluble with alcohol. We know that that is a turpentine oil. That then what is turpentine oil, in which in turpentine liniment the turpentine oil is a disperse phase, then or either continuous phase or a disperse phase, right? And then soft soap, it is a act as emulsifying agent, then water are act as a either disperse phase or continuous phase. Means in a liniment means it is a water is a act as a disperse phase, turpentine oil act as a continuous phase, and soft soap act as a emulsifying agent. And that alcohol or common solvent has a property that dissolve with a turpentine oil, soft turpentine oil, soft soap or water, and due to this they make able to make a clear solution or on phase solution. And due to on phase solution or clear solution, there is a cracking occurred, right? So this is the all about the our addition of common solvent, right? So you should remember this. Then after another our fourth reason, that is a by a microorganism. By a microorganism, due to the microorganism, formation of microorganism or presence of microorganism in our preparation may also lead to cracking or a separation of our emulsion, right? So you should remember bacteria or microorganism also responsible for the separation or a cracking if emulsion is not carefully stored, right? So this is the one accidental condition, that is if we by chance we fails to store the our emulsion carefully or at a suitable place or suitable temperature or suitable environment, right? That time also chances of microbial attack, right? So if emulsion is not carefully stored, may chances of bacterial or mold growth, right, lead to destruction of emulsifying agent, hence emulsion become a crack, right? So there is a reason, that is as I said, that is if we accidentally or fail to store the our emulsion or fails to preserve the our emulsion with a proper precaution or carefully, right, or fails to addition of any preserve antimicrobial agent, right, that time may also the formation of separation, because if we uncarefully or does not take a or we do fails to take a care of our emulsion during the storage, that time a chances of occurring the bacterial or mold growth into our emulsion, right, into our emulsion. So if bacteria or mold growth into our emulsion, that time whatever the emulsifying agent we added into our preparation, they become destructed or spoil or decompose, right? Can we know that is a also natural kind of emulsifying agent are sensitive with the bacteria or mold growth, because it contains the carbohydrate, and carbohydrate is a good media for bacteria or mold growth. So this is the reason if we fails to store the emulsion carefully, that time may chances of occurring the uh, growth occurring of bacteria or mold, right, in the emulsion, and due to the bacteria growth of bacteria and mold, there is a chances of destruction or spoilage or degradation of our emulsifying agent. If the emulsifying agent degraded or destructed, that time whatever the emulsion, that become a cracked, right, to be cracked, that is separation, right? So this is the reason. So by the microorganism, this is the another reason for occurring the separation or cracking of emulsion during its storage, right? So we should take care of this kind of points, right? Then afterward, if the emulsion is not carefully stored, may chances of bacteria or mold growth lead to destruction of emulsifying agent, hence emulsion become a cracked, right? Hence it is a desirable that all emulsion should store for a long period with a careful preservation. So there is a recommendation or suggestion for preservation of emulsion, if right, if we uh, wish to preserve our emulsion, right, or it is a desirable that, or it is a necessary that the all emulsion should be stored for a long period. If we wish to store for a long period of time, that time we should take care we should take a care of it, that is a preservation, right, by adding the various kind of preservative, right? So during the storage we need to careful preservation of that, right, by preventing the microbial growth, right? So by this way we can overcome the our separation or cracking problem, right? Then there is a change in temperature. So change in temperature and by creaming, these are the another reason by which there is a chances of occurring the creaming. So these two reason and our second kind of changes or instability problem we will discuss in our next lecture, right? So let's summarize it. So as what is the stability, I think you are understand, then cracking, then creaming, then phase inversion, right? So remaining portion we will discuss in our next lecture. Okay, thank you.